Okay, hello everybody. You can all hear me? Yeah, great. Okay, let's get started. My name's Tim Fox. I'm going to be talking about, well, you can see the title, Polyglot Reactive Application Development with Vert.x 2. Basically, I'll say a few brief words about myself. I'm currently employed by Red Hat, where I unsurprisingly lead the Vert.x project. Before that, I worked at VMware, which is now changed to Pivotal for a little while, with the RabbitMQ team. And while I was there, that's where I created Vert.x. Before that, I was actually at Red Hat again for about 5.5 years, where I led messaging development. And in particular, one of the things I did there was I created the Hornet Queue messaging system. And that, if you're not familiar with that, that's the messaging system that's inside JBoss application server, which is now called Wildfly. And it's also in the JBoss Enterprise Application Platform, which is their our main product. So that's enough about myself. So what are we going to talk about today? So basically, this talk is going to be a kind of overview and introduction to Vert.x, but also I'm going to talk about some of the new features in Vert.x 2, and I'm kind of going to spice it up a bit with a few demos. So there's going to be like 5 or 6 kind of simple demos to show you stuff. It's kind of more interesting than boring slides. How many people here already are pretty familiar with Vert.x? I just want to get an idea. Okay. And how many people don't really know much about it, but just thought it'd be interesting to sit in here? Okay, so probably more people don't know about Vert.x. So the things with Vert.x is actually quite a low-profile project. We don't do a lot of marketing. In fact, the only marketing that I do, the only marketing that really happens is me tweeting. It's an independent community project. We basically transitioned over to the Eclipse Foundation earlier. Well, it's kind of ongoing still, but we started earlier in the year. So the main project is actually a project of the Eclipse Foundation, and that's a really good thing, because it means that no one company is controlling the project. It's in a neutral kind of entity. All the code's on GitHub, like most projects, open source projects. We're open source. I mean, do I really need to say that anymore? I mean, how many projects that you've heard about in this conference are not open source? Probably not that many. So it's kind of the norm now, isn't it? We're one of the most popular Java projects on GitHub currently to go by number of followers. We're like number 9 or 10, I think. Right, so overview of Vert.x. What is Vert.x? How would you describe Vert.x? Well, it's a lightweight, general-purpose reactive application platform. Okay? So you've probably heard this word reactive said quite a lot recently. It's a kind of a buzzword at the moment. But yeah, it's basically a reactive platform. I mean, it provides primarily asynchronous APIs that you program against, which is one of the features of reactive. It's polyglot. I think this is the unique selling point of Vert.x compared to other reactive application platforms. We're not just one language. Okay, you can develop your application if you want. You don't have to, but you can develop it if you want, different components of your application in different JVM languages. And I'll talk more about that in the next slide. This is kind of a unique thing about Vert.x. It's high performance. Okay, you don't have to believe me. Go to, who's heard of Tech and Power benchmarks? Okay, a few people. Tech and Power is a company, an independent company, nothing to do with Vert.x, who've put together a set of benchmarks. And they've basically benchmarked pretty much every single framework or application that exists today, not just JVM stuff, kind of, Rails and Node.js and everything else. And we're pretty much right at the top there. In fact, the top 3 places are all Red Hat-sponsored projects, which is pretty good. Yes, they're really fast. Node.js, right? Superficially similar to Node.js. This is something that gets said quite a lot about Vert.x. It's kind of, if you want to describe Vert.x in one sentence, a lot of people say it's Node.js for the JVM. Okay? And that is true to a certain extent. We have primarily asynchronous APIs, but we go further than Node.js. We have a lot of features Node.js doesn't have. We have better performance, and of course, we're not just JavaScript. You can use JavaScript if you want, but you're not compelled to use it. We'll talk more about that later too. Simple, but not simplistic. So when I created Vert.x a couple of years ago, one of the main goals was to basically get away from the perceived complexity of traditional Java application platforms that are around. So we're getting away from the idea of an application server, getting away from the idea of complex XML configuration. So this is one of the kind of important things about Vert.x. And it's embeddable. So you can actually embed Vert.x as a library. If you don't want to use the whole platform, you can embed it as a library in your existing Java applications. I won't go into too much detail on that right now because we haven't got time. Right, so I mentioned Polyglot. So right now, we support, when I say support, I'm not talking about paid support. I'm talking about, we fully implement it with all the documentation, all that kind of stuff. So we fully support Java, obviously, JavaScript, Ruby, Groovy, and Python. And we have kind of beta-level support already for Clojure, Scala, and PHP. And I'll show you a Scala example a bit later on. So when I say beta-level support, I mean it works. The API is not quite finished yet, and then we're kind of lacking documentation. But apart from that, it works. And over the next few months, that should migrate up to fully supported. OK, so before we get into demos, I just want to talk a bit about the asynchronous API. So at the heart of Vert.x, we have a small set of APIs that you develop against. And the core of Vert.x is very, very small and static. When I say static, I mean we don't envisage that changing much over time. And the APIs kind of do stuff like, if you've used Node.js, you kind of be familiar with the kind of things it does, right? So similar kind of stuff at the core, right? So we've got APIs for creating TCP, clients and servers, HTTP. We have full WebSocket support for doing your kind of real-time web applications. We also have sock.js support, which if you're not familiar with sock.js, it's a bit like WebSockets, but it's an abstraction. It abstracts actually over the underlying transport, so it'll still work even if your network or your browser doesn't support WebSockets. It will fall back to polling or various other transports. We have asynchronous file system support, and we have the Eventbus. Now, the Eventbus is probably one of the most important features of Vert.x, and I'm going to go into a lot more detail on what the Eventbus is and why we have it and what it does. We have some new stuff, DNS, UDP, yeah. So basically, the core of Vert.x is very small and static, and it's asynchronous APIs. So why asynchronous? Why can't we provide direct-style synchronous APIs? Because arguably, direct-style synchronous APIs are easier to program against, so easier to reason about, easier to debug. So we don't want to do asynchronous unless we really have to. So why do we have to? And it's all about scalability. So modern breeds of servers, whether they're web servers or maybe like WebSockets application servers, or servers for the Internet of Things, like MQTT servers. You may have heard quite a lot about IoT recently. All of those are characterized by many long-lived connections. Okay? And if you have a blocking thread per connection model, then you need as many threads, OS threads, as you have connections. And obviously that doesn't work when you've got a million connections. Operating system threads are lightweight compared to how they used to be, but they're still not really that lightweight. They still have overhead in terms of the RAM, the stack, and context switching overhead. So we have to go to a non-blocking approach for I/O. And because we use a non-blocking approach to I/O, that feeds through to the APIs the user uses too, because we're not using a continuation-based approach to abstract that out, because that doesn't work very well on the JVM. So that's why we've taken an asynchronous approach. OK. So how do you write an application in Vert.x? Fundamentally, all Vert.x applications are composed of things called verticals. And a vertical is the execution unit of Vert.x. It's a lump of code that gets executed. And a typical application in Vert.x will be composed of many verticals. I mean, a trivial application with just one vertical, but a kind of real-world application will typically have more than one vertical. A vertical is single-threaded. There is actually an exception to that, but I won't go into that now. But generally, verticals are single-threaded. So Vert.x guarantees that no more than one thread executes your vertical at any one time. And in many cases, it's the exact same thread. So what does this buy you? It buys you less scope for race conditions. You don't have to worry about synchronizing stuff. You don't have to worry about volatile. A lot of deadlocks just don't happen. A lot of race conditions don't happen. Okay? This buys you a lot. It's a very good approach to concurrency. It's getting away from the bad old world of Java-style multi-threaded concurrency, where you're letting multiple threads run through your code at the same time. And verticals can be written in any of the languages that Vert.x supports. And the fourth feature of vertical is they communicate by message passing. So how do they talk to each other? So you have multiple verticals in your application. They talk to each other by passing messages over the event bus. So you may be thinking by this point, hang on a second, this sounds a bit like the actor model. You know, you may be familiar with Erlang or Akka or something like that. And it is very similar. The concurrency model in Vert.x is very similar to the actor model, and it's a good model for concurrency. Okay, so let's take a little look at some verticals. So let's start off with some hello world verticals. So in this directory here, I've got a couple of files. I've got hello-world.js, and this is a JavaScript file. It's a JavaScript vertical. And what we've got here is what we call a raw vertical. In Vert.x, you can run raw verticals directly at the command line, and it makes them very good for like prototyping and demos. In a real application, you would typically package up all your verticals into a module and run it that way, but we're not going to do it that way yet, so I'll show you that later. But for now, we're going to be running raw verticals. So let's actually look at hello world.js. And as you can see, it's a kind of trivial vertical. What it's doing, it's creating an HTTP server, and then it's setting a request handler on that server. And the request handler is simply a function that will get called whenever an HTTP request arrives on the server. And when that happens, it's just going to return hello world from JavaScript, right? Pretty obvious, even for those of you who are not used to asynchronous APIs. So let's run that. So the way to run that in Vert.x, at the command line, say Vert.x run, then the name of the file. Okay. Now, let's go to a browser. I should have shut all my tabs down, never mind. Oh, the wrong one. That's my Twitter account, you don't want to see that? There we go. Okay, so trivial example, you can see it works. Now let's go back to the vertical again. And in the same directory, I've got another one called hello-world.java. And this is a Java vertical. So this time it's a vertical that actually does pretty much the same thing, this time written in Java. So let's have a quick look at that. Hello world Java. As you can see, it's a bit more verbose. That's because it's written in Java. And it will be more verbose until Java 8 comes out and lambdas arrive. But it's pretty much doing the same thing. You're setting a request handler. In Java less than Java 8, you have to basically have a class that implements the handler. Right? So that's why we have to create an anonymous class there. But it's doing the same thing. So let's run that. Java 8 will be really good for programming against asynchronous APIs because you've got the Lambda. It makes it a lot nicer. Right, so it's a Java source file, so we've got to compile it first, right? No, we don't. We can just run it directly with Vert.x. So you can do Vert.x run. Forget all that stupid compiling stuff. So what it'll do, I mean, if I had to compile it, I'd have to compile the classes, put them somewhere, work out a class path, blah, blah, blah. Vert.x will compile Java source files on the fly, so you can run them directly. So you're kind of almost treating Java a bit like, but it's not a scripting language, but kind of in that sort of way. And then if we go back to our, there we go, back to the web page, hello world from Java. Yeah. Okay. So that was the first, and the demos will get a bit more interesting as we go along. The event bus. So I mentioned the event bus was like a really important feature of Vert.x. And it is the nervous system of Vert.x. It's the means by which all the verticals talk to each other. So I mentioned before, the verticals themselves are kind of single-threaded things that send messages over the event bus. The event bus itself is a lightweight messaging system. It supports all the common messaging patterns, like point-to-point messaging, pub-sub messaging, and request-response messaging. And the things that you can pass on the event bus are strings, buffers, byte arrays, all the primitive types, all the kind of normal stuff. But what we actually recommend, really, that you use is JSON. Why is that? If you think about it, your application may be composed of many different verticals written in different languages. You may have a Scala vertical talking to a Ruby vertical, talking to a JavaScript vertical. So we need like a lingua franca that all those languages can understand. And there's one thing that's really easily understood by all those languages, or most of them, is JSON. JSON's very easy to parse, it's very easy to generate, it's very easy to read. So by convention, we say, especially for module-module interactions, use JSON. But it's not a rule, it's just a guideline. But we take the event bus a step further, and we actually cluster the event bus, right? So it not just allows verticals in the same JVM instance to talk to each other, it actually allows them in different places in your network to transparently talk to each other, irrespective of where they're actually living on a network. So it connects multiple JVM instances. So we end up with this kind of vision of how you create a Vert.x application. We're moving away from the application server model. So with an application server model, you start up an application server and you deploy stuff into it. With Vert.x, you don't have an application server. You simply run stuff directly wherever you want it, and then it talks to each other over the event bus. So you can run different parts of your application in different places in your network, depending where you want them to be. And you can write them in different languages based on the skill set of your teams or the job at hand for any particular component. The actual clustering right now, it's totally pluggable. It's currently by default using Hazelcast, which is a great little clustering library, but that could actually, you could plug in, implement a couple of interfaces, and you can plug in, say, InfiniSpan or JGroups or something like that. And we take the event bus a step further still, so we actually can extend it into client-side JavaScript too. So you can actually use the same API in your JavaScript running in Firefox or Chrome or whatever to send and receive messages on the event bus in client-side JavaScript too. And I'll show you that in just a second. So this is like leading towards making Vert.x a very good choice of so-called real-time web applications. By real-time, I mean kind of like the very responsive, modern-style web applications pushing data from the server to clients. And on the client side, you can use whatever toolkit you want. We don't preach about what you use on the client side. So you can use, say, AngularJS. We actually have a demo application in the repository that uses Angular. Or you can use whatever you want, straight jQuery. It's just, the client-side libraries are just JavaScript libraries, so you can use them for whatever you want. So let's actually have a demo of the event bus. So let's move into a different directory. Right, so I've got some more verticals here. So I've got a vertical there called receiver.js. So let's have a quick look at that. This is obviously a JavaScript vertical. And this is now showing usage of the event bus. And it's again, a trivial example. It's basically subscribing to a news feed. It's doing the subscribe part of publish-subscribe messaging. So it's registering a handler. I imagine it's quite obvious what's happening here. You're registering a handler against an address, an arbitrary string, and the handler is just a message, and the message, it's just a function, and the function will be called with a message whenever data is received on that topic, effectively. So let's run that. So we Vert.x run, receiver.js. Now this time, I'm going to add the cluster flag. And what that's telling Vert.x, it's saying, if any other vertexes subsequently appear on the network, I want you to talk to each other. Yeah, so you form this big kind of address space. Now, receiver by itself is not much use, is it? So we need something to send. Some messages. So we also have, hey, let's do a bit of Scala, right? So I happen to have a vertical called sender.scala there. So let's take a look at this. And this is still beta Scala. So the API might actually change still. But effectively, it's doing the same thing. It's simply publishing a message. Every second, a timer is going to fire. And when that timer fires, it's going to publish a message to that news feed that we mentioned the receiver was listening on. So hopefully, the receiver should pick it up and log it out to the console. So let's run that. So we have Vert.x run sender.scala, again, minus cluster. Okay, and if you notice again, we're running the Scala source file directly here as a script, effectively. And Vert.x supports both Scala compiled files and Scala scripts. Okay, so let's go back to the other window. And as you can see, the receiver is now picking up every second. It's picking it up and it's logging it out. So let's make that a bit more interesting, and let's bring in the client-side JavaScript now. So, client-side JavaScript, we need to serve a page to the browser, right? So we've got a page there called index.html. Let's have a look at that. I keep switching between nano and less, I know. And it's a very simple HTML page that basically, it's just got a bit of JavaScript in it. Very simple bit of JavaScript, which opens the connection to the Vert.x Eventbus. And when that connection is open, it's just going to register a handler exactly the same as what we just did on the server side against the same news feed. And when it receives data on that news feed, it's just appending that to the page, the HTML on the page, using a bit of jQuery, a bit of trivial jQuery. So the idea is as data comes in, it should display that. Right, so we're serving a web page, so we need a web server, right? So let's write a web server. Well, actually, I've got one here already wrote. So there you go, bridge server.js. Let's have a look at that. Again, written in Vert.x. Just a few lines of code. Actually, the web server bit is just those 3 lines of code in the middle. And the create HTTP server as well. And all it's doing, you're creating an HTTP server, you're setting a request handler on the server, and when the request comes in, you just basically, if it's a request for the root, we're going to serve index.html. Otherwise, we're going to serve the actual file that's been requested from the path. And a bit further down, with another line, says create a sock.js bridge. I won't go into detail of that now, but this is the bit that kind of bridges the client-side event bus to the server-side event bus. Don't worry about that too much for now. Oops. Right, so let's run that. Vert.x run, bridge server.js minus cluster again. Oh, sorry, I spelled run wrong. OK. And now we can go to a browser, if we refresh, and there we go. It's now picking up that same Scala vertical that was running from before. Okay. Let me just get rid of those. Yeah, so that's pretty cool. So you've got this idea of one kind of event space that encompasses not only your server-side nodes, but all your browsers too. So you have browsers talking to browsers talking to servers, servers talking to browsers, etc. Okay, and we'll touch back on that later on when we do high availability. Another really important feature of Vert.x is the module system. Vert.x has a module system. So what is a module? A module is something that encapsulates the code and resources of your application. And a typical Vert.x application can be, well, a simple Vert.x application may just be composed of a single module, but for larger applications, you may have several modules. A module contains a file called mod.json, which is a descriptor file. It just tells Vert.x a few things about the module, like how to start it and things like that. And a module contains 0 or more verticals. A trivial module might just have 1 vertical. But typically, you'd have more than 1 vertical in one. And you can have verticals from many different languages in a single module. Modules can be runnable or non-runnable. I won't go into non-runnable modules here because we don't have time. But most modules are runnable, which means you can execute them. You can start them. And I'll show you that in a second. And finally, modules provide class loader isolation. So modules have their own class loaders, and class loaders are arranged in a hierarchy. And the reason we do this is so that if you have an application that, say, uses module A and module B, and module A uses some jar library of one particular version, and module B uses the same jar library of a different version. If we had a flat class path, that wouldn't work, right? So we need some sort of way of being able to isolate them. You can actually configure Vert.x to have a flat class path if that's what you prefer, but by default, it doesn't have a flat class path. So let's actually. I mean, it's easier to actually see some modules, I think. So let's just shut down this one, and I'll show you some modules. Fundamentally, a module is basically It's basically a directory on the disk. So I've got a directory here I prepared earlier. I'm just going to copy it over to another directory. So we've now got a directory called mods in the current directory. And the mods directory is a very special directory in Vert.x. It's the default place where Vert.x looks for modules. When you run execute a module, the first place it looks is in the local mods directory. That can be overridden, but that's the default place. So in this mods directory, I've got another directory has a longer name. And this is the module, right? The module is just a directory that contains stuff. And the naming should be familiar to you if you ever used something like Maven before, because it's actually very similar to a Maven coordinate. It's composed of 3 parts. The first part is the group, effectively the Maven group ID. It maps directly to that. The second part is the module name, and the third part is the version. So all modules must be named in this way. Let's have a look inside the module. What have we got here? It's a trivial module. We've got a groovy, bit of a variety in the languages. Now let's do a bit of groovy. Okay, so we've got a vertical written in groovy this time. Let's have a look at that. And it's the same example from before, right? So it's going to create an HTTP server. This time it's going to return hello world from groovy. And let's have a look at the descriptor file. Now, I said before, all modules must have a descriptor file, so here is the descriptor file. So let's take a look at that. And this is a very simple module. All it has is a single field called main, which tells Vert.x when this module is run, the actual thing that you need to execute is this vertical, because there could be more than one vertical in the module. OK, so how do we run a module? So we go back up a couple of directories. You run a module by saying, instead of Vert.x run, you say Vert.x run mod, and then the module name. So Vert.x hello mod 10. Okay. Oh, and the reason that happened is because I've still got a server running, and they're trying to listen on the same port. So I need to shut down. This happens to me every time. I always forget to shut it down. So to shut down the other verticals we had running from the previous one. Then we just try again. OK. Let's go back to our web server. Oh, sorry, our browser. And there we go, hello world from groovy. So it's run that module. OK? Let's do something slightly more interesting. Let's shut it down. Let's delete that mods directory. Now, this will only work if I've actually got a network connection, which I did have problems earlier. So if it doesn't work, don't blame me, blame the venue. rm-rf mod. So I'm going to delete that modules directory. We don't have a modules directory anymore. I'm going to try and run that same module again, the same command line we just did. See what happens. OK, something happens. Let's go back to our browser. F5. Oh, it's still running. Well, it's running, right? So how did that happen? I just deleted the module, right? So how did it actually run it? So what actually happened there was, I said before, Vert.x first looks in the mods directory. If it can't find it there, it then looks in various other places. And one of the places that will look is Maven Central. And it just so happens that I've put that module in Maven Central a while back. So when I ran it then, it pulled it out of Maven Central, downloaded it, put it on the disk, and then ran it from there. And actually, if you look on the disk now, you'll see that mods directory has reappeared, and it contains the same module. So Vert.x can basically resolve module dependencies at runtime. It doesn't have to be at build time. So it means that you can actually deploy a Vert.x application with a very small little stub, and it will just pull in everything at runtime if it needs to be. I know a lot of people don't like to do it that way, because they like to package everything up at build time because of compliance reasons and stuff like that. So we actually support both ways of doing it. But this is kind of a nice feature, I think. Modules. What is the purpose of these? Modules aren't just about encapsulation. They're about encouraging an ecosystem of modules. So we want the community to create modules that do all sorts of different things under the sun, so that when you want to write an application in Vert.x, you can simply say, oh, I want to write a web application, a kind of real-time web application. So I'm going to use that module there, that database module. I'm going to use this one here, this web framework module, put them together in a certain configuration. You've got your application. Because Vert.x itself is very unopinionated. We don't say, this is the correct way to write a web application. We don't say, this is the correct way to write an enterprise application. We want to have a whole load of modules that do all sorts of different things. we let modules live in all the normal places that you'll already be used to as JVM developers, or most likely you're already Maven users, right? So you can put modules in Maven Central just like you put any artifact. Okay, so you can reuse, if you've got your own Nexus repository, you can use that, or if you're using OSS Sonatype or whatever, we can use that. You can also use Bintray, which is the new repository by the JFrog guys. Yeah, so basically we want to encourage this ecosystem of modules so you can, basically do everything under the sun in Vert.x. So the core of Vert.x stays very simple, not much functionality in the core. Most things are in the form of modules. And here are some selection of the modules that already exist. We have database stuff like Mongo, Redis, MySQL. Got some Jersey stuff for REST, some Spring integration stuff. There's a really interesting module there called Node.js, and what that is it's not actually complete yet, but this will be drop-in Node.js compatibility for Vert.x. So if you have an existing Node.js application, you'll be able to run it directly on Vert.x. And what this will buy you is, apart from better performance, better scalability, it'll open you up to not just JavaScript. You can start to extend your application to different languages. And you also have access to all these cool things like the Eventbus and stuff. Another interesting module there that's worth talking about is RxJava. How many people here have heard of RxJava before? Okay, it's a fair few. Normally, only about a third of the people who actually know about it put their hands up, so we'll kind of multiply it by 3, and that's the real figure. So if you're not aware of RxJava, it's a very cool, well, the module is based on a very cool project by Netflix called RxJava, which in turn is based on reactive extensions by Microsoft. And what it is, it's a way of composing asynchronous flows of data in very intuitive ways, kind of functional ways. Yeah? And why do we do this? Because, when you programming against asynchronous APIs is arguably hard, especially when you've got lots of callbacks and stuff, coordinating them. You must have heard of callback hell, or the pyramid of doom, a kind of classic ways of describing having lots of nested callbacks. So something like Rx is a way of mitigating against that. So those are the modules. And the last thing I'll say on modules, a really cool feature we've just introduced is something called fat jars. So what is a fat jar? A fat jar is a single executable Java jar which contains everything, apart from the JDK, that's needed for your application to run. Okay? So you can actually convert any Vert.x module into a fat jar, and then you can copy that jar to any machine, to your server. It doesn't have to have Vert.x installed on it already, and just directly run it. As long as you have a JDK installed, just directly run it, and it'll run. Okay? And this is kind of good for DevOps. You don't have to worry about all the different configurations of different frameworks and platforms and all that kind of stuff. They just want to copy a jar and run it. All they have to have is the JDK running. So let's actually take a look at that. Let's go back to the previous example where we ran that module, that groovy module that had a simple HTTP server in it. So let's convert that module into a fat jar. All we have to do is use the same command line as before, and we say, instead of saying run mod, we're going to say fat jar. Okay, ls, and there it is. So we now have an executable jar that we can just run using Java. So Java -jar hello mod. Oh, yeah. Okay, let's go back to our browser. Yeah, it's still running. I mean, you don't see a change because it was from the same page as before, but it's running, yeah, it's working. So that's a pretty cool thing. And that's actually proven to be very popular, fat jars. Okay, let's move on to HA, high availability. One of the new things in Vert.x 2 is HA support. What is HA? I think everyone here probably knows what high availability is. If you don't know, in a nutshell, it's the ability for your application to carry on functioning after the failure of one or more parts of the application. So it's actually a part of if you've read the reactive manifesto by the TypeSafe guys, which I do buy into, it's part of the whole reactive thing is resilience under failure, right? So yeah, we support automatic failover of deployed modules. And what this means is you can have your modules running on your server, And you can, if you have more than one node, if one of the nodes goes down, another node will take over responsibility for those modules. You can group your nodes into logical subgroups. So you can have, say, a particular application only failing over to a certain subgroup of nodes. If you want to group your nodes into for different reasons, that's fine. And we have network partition detection using Quorum. I'm sure most of you who've configured HA before will know about the principles of a quorum. I won't go into it now. It's a very well-known principle in distributed systems, and you can Google about it if you want. But I will show you an HA demo. So let us make sure we shut everything down this time. Yeah. Oh, LA, no. Right, so I happen to have another modules directory here that from before, that I prepared before, and I'll copy it over now to mods. Right, so I now have another mods directory which contains two modules. This time there's one with a vertical written in Groovy, another one with a vertical written in Python. And let's have a look at them. So let's go into the Groovy one. Oh, sorry, I'm in the wrong directory. ls mods Vert.x Groovy sender. Sorry, CD, what am I doing? Excuse me. Right, so it's basically the same module we saw before. Sorry, the same example we saw before with a Eventbus sender, this time written in Groovy. So it's just going to be every second, it's going to be publishing to the news feed, hello, news from Groovy, okay? We've seen that before. Now let's take a look at the other one. CDI Vert.x Python sender. And again, same thing, but in Python. Just for a bit of variety. Okay, every second it's publishing to the news feed. So let's run those modules. So again, we're going to, let me just ls mod, sorry, the names. Okay, so this time Vert.x run mod, as before. So let's first run the Groovy one, Groovy sender. But this time we're going to run it with HA enabled. So how do you do that with Vert.x? Like most things in Vert.x, it's very simple. You just put HA on the command line. Okay. Let's go to another console and do the same with the Python one. So Vert.x run mod, io Vert.x Python sender minus HA. Okay. Takes a couple of seconds to start to form the cluster. And so we've got two senders now, right? Now we need the receiver, so otherwise we can't see. There's nothing subscribing to it. So let's start up the bridge again and have a look at it in client-side JavaScript. So Vert.x run bridge server. This is the HTTP server before that did the bridging and served the static files minus cluster. Give that a couple of seconds to start up. And if we go to the browser, and there we go. So we've got the two senders. There's two sender modules on the server side sending to the client side JavaScript. Now let's show the HA in action. Right. So let's find out kill one of those processes. So let's find out the process ID of the Python one and kill it. 1458. Anyway, you can see it's been killed. And you can see this other one, the process that was running just the Groovy one before, has now taken over the Python one too. Yeah? So you've now got, whereas before you had two JVM processes, one running Python, one running Groovy, now you've got one running both of them. And if you look back on the browser, it's still running, yeah? They're both still running. So nothing failed, even though the process failed. Now let's do something even cooler. Let's start up an empty Vert.x node with nothing running in it. So you can do that just by Vert.x minus HA and you're not actually running anything initially. Okay, so now we've got two Vert.x processes running, one with nothing in it and one with two verticals running in it. So let's kill the one with two running in it. So let's find, that's the one that was originally called Groovy Sender, so I can just grep for that. So let's kill that. -9, 1, 3, 9, 6. Go back to, that's killed. And this one, oh, did I spell it wrong? I think I spelt it wrong. Yeah, so I haven't actually got time to go through that again now, but trust me, it does work. I just spelled it on the command line. So what would have happened there is it would have carried on, and you would have seen it on the browser still. Yeah. Okay, Jay, apart from a little hitch at the end there. But the idea is then you've got the resilient part of reactive too. Okay, so the final thing I want to talk about is about developing with Vert.x. So one of the things we really spent a lot of time trying to have a good experience in Vert.x 2 is the whole development process. So in Vert.x 1, we're a bit kind of rough. We didn't really have much IDE support or build tool support or anything like that. Now, Vert.x itself is IDE agnostic and build system agnostic. You can just use a text editor if you want. But we realized that most developers, especially JVM developers, tend to use IDEs, and they tend to use build tools like Maven or Gradle. So we need a story there. So we have a Maven archetype that you can basically just create a Maven Vert.x, a project that creates a Vert.x module using the Maven archetype, just one line, it'll create a skeleton project for you. We have a Gradle template in GitHub. You can clone that. You basically clone that, and you have a Gradle module project that you can get started with immediately. We also spent quite a lot of time working on transparent debugging and testing of verticals especially in IntelliJ IDEA and Eclipse. And another cool feature I'll just show you is something called module auto redeploy. So what this means is you can basically be developing, you can have your module running in the background as you develop, and as you change stuff in your browser, like edit a file, you just save it, and your module will automatically pick that up and redeploy it without you having to build anything or manually start or stop anything. And hopefully we can try that now. So, right, so we need the bridge server running again. So let's go back. I'm going to basically do a similar example as before. Let's run the bridge server. Vert.x run bridge server JS minus cluster. And in this directory here, I have a Gradle project. You could do it with Maven if you want as well, but I just happen to do it with Gradle. That I'll show you now in the IDE. So I've got IntelliJ running here. And it's just a simple project, which, again, it creates a module which does the same thing as before. It publishes to that newsfeed, this time written in Ruby. So every second, it's going to publish to that newsfeed. And it's running, this is a Gradle project in IntelliJ IDEA. So let's run that using we have a Gradle target that can be used to run a module from the resources in the IDE. So let's actually do that now. So Gradle run mod IDEA -i, because otherwise the Gradle will swallow all the output. Okay, it takes a little while for Gradle to start up and do its stuff. Okay. So let's go to our browser. There we go. So the browser is picking up, as you would expect, it's picking up what that module is sending on the server side. So let's go and change something in the module. So let's say some more news from Ruby. Save it. Let's go back to our browser. And there we go. It's picked it up immediately and rerun it. And basically restarts the module for you. This is a kind of cool feature that makes the whole development process kind of nice when you're developing verticals in your browser. And you don't have to recompile or anything. Yeah, so that's basically it. So I'm going to summarize now. So what does Vert.x buy you? You know, it's a reactive platform. Vert.x is one of the new wave of reactive application platforms. I think this is where the industry is going. You've got, you know, other examples, obviously type-safe stack. Vert.x is a good example. I think this is going to get a lot more traction, the whole reactive thing. So it allows you to write apps, a set of loosely coupled components that you can, all the bits of your application can live wherever you want on your network, depending on the appropriate place on your network. So there's no monolithic app server anymore. You can write different parts of your application, potentially in different languages. You don't have to use different languages. There's no point using different languages for the sake of it. But typically, you might have, say, a web team that, you know, likes to use JavaScript. It's appropriate for the task in hand. You may have some sort of back-end processing. You want to use a statically typed language like Java or Scala. That's fine. We have a very simple actor-style concurrency model, so you can wave goodbye to most race conditions, deadlock, all that kind of nasty stuff that you'll be familiar with from traditional Java-style multi-threaded concurrency. And we have a module system, so we want to empower the community. We want to end up with a whole large array of modules to do everything under the sun. So when you want to write an application, you pick several modules, put them together according to a recipe, and then you've got your application. Because Vert.x itself is non-opinionated. We have HA, which gives you the resilience part, and we have ease of development. We still need to work, but we have still more to do on ease of development, but we're getting there. And that's pretty much it. So, yeah, we are a very small team, loads more to do. I mean, if you're interested in taking a look, getting involved, helping out, you know, writing some modules. We have an active and growing community. We do all our development on GitHub. We have a Google group, which is, you know, discussions and stuff. And we have an IRC channel, which most of the main developers hang out in. So it'd be great if you can get involved. So, yeah, thanks for listening. I hope you enjoyed the talk. Any questions? Down the front here?
Yeah, can I ask, in terms of security, how it's all covered? I noticed the Eventbus there, there's some comments saying, you know, watch out, events are exposed.
Yeah.
Can you give us an overview of that?
Yeah, so for the client side of Eventbus, so on the server side, we assume all the stuff on your server side is in a trusted network, right? But obviously, when you move it to the client side, you need some sort of firewall or something to stop people just getting messages from anywhere. So we have a kind of effectively like a firewall you can configure. You can say only these types of messages are allowed through either way. You know, only allowed to register according to, on certain addresses, and you can use a regex and stuff like that to define that. Yeah. Any more questions? Just here.
How about scalability? Do you have some performance measurements?
Oh, right. So the question was, how about scalability? Do you have any performance measurements? We haven't done any kind of like, you know, we don't have machines to do it on, so we don't have a kind of big lab where we can do big scalability experiments. I said before, there are some independent benchmarks. The Tech in Power benchmarks came out, and we're like right at the top. In terms of the kind of ad hoc stuff we've done, we scale very, very well. Yeah, and actually, if you could actually look on the Tech in Power results, we scale almost linearly with numbers of connections. So yeah, it would be nice to have a big lab where we could actually, you know, lots of machines and like do some really hardcore testing. But unfortunately, we don't have those resources right now, so we can't do that. Any more questions? There's a guy kind of up there.
Does the Eventbus do reliable and guaranteed messaging as well?
So the question was, does the Eventbus do reliable and guaranteed messaging? The answer is no. It's a lightweight messaging system. You know, I've written messaging systems that do reliable and guaranteed messaging, and you know, reliability makes things a lot harder, right? And also slower. And so we don't go there. Basically, we're not trying to compete with, you know, your enterprise messaging systems like, you know, HornetQ and ActiveMQ and all that kind of stuff. It's a lightweight messaging system for the purposes of sending messages around. And there are other approaches to reliability that don't involve persisting messages. You can try and make your stuff idempotent and resend stuff, and you know, there are different ways you can do it. But we don't want to make it into a kind of enterprise messaging system, no. A question down here at the front?
You said it could be embedded. What can be the issues with the class loading, the scoping of the class loading of modules when you are embedding?
Okay, the question was, I mentioned before Vert.x can be embedded. Are there any issues with the class loading when embedding? So, when you can embed Vert.x in two different ways, so two different levels of embedding. One is embedding just the core of Vert.x. Another bit is embedding the Vert.x platform, right? Now, the platform is the bit that has the module system and the class loaders, right? But you don't have to use the platform you don't want. You can just embed the core libraries, which is all the kind of like TCP clients and servers. It's basically a networking library and file system and stuff as well. And you can embed all that stuff in your application too. And that doesn't have any of the class loader stuff in it. So that will work with your pre-existing class loader model. Any more questions? I think that's it. Oh, sorry, one more down here.
Would you require async, let's say, drivers or libraries to communicate with external resources like databases, or do you have a way to deal with synchronous I/O there?
Good question. So the question was, can we do all the drivers also have to be async, right? And this could be a problem in the JVM world, because a lot of traditional, like JDBC, is inherently synchronous, right? So how do we deal with that? So we actually have something called a worker vertical in Vert.x. We're not strictly asynchronous. You can actually do synchronous stuff in Vert.x too. So if you want to talk to kind of like legacy standard kind of Java synchronous APIs, you can execute it on a worker vertical, which runs on a thread from a thread pool. You can do JDBC in Vert.x, right, and other things that are blocking. But we have, for instance, our MySQL support. That's actually a pure asynchronous MySQL driver. And the guy who wrote that, what he did, he actually reversed engineered the wire protocol for MySQL and wrote it from scratch. So it's actually pure async. But we think supporting worker vertical is kind of a key value add for Vert.x. So you can use a lot of the existing libraries. Yeah. Any more questions? Oh, there's one up right at the top there.
So when you start up a new node and you're using high availability, does it receive the modules from the existing nodes? Do they get sent during runtime?
No, it doesn't receive them, no. So they have to be either pre-installed or available in a repository like Maven or Maven Central or whatever. Yeah. So it won't actually pass the module across. It just passes the module name, and then it kind of goes through the normal installation process. So you either have to ensure they're already on all nodes, or put them in, say, your own Nexus repo, and then they'll just be pulled in when they're needed. And we're done here?
Following up on what you just said, your demo that broke at the end there, that's what you were trying to show, right?
Yeah, so the one that broke was the last bit of the HA, wasn't it? Which is... Yeah, so I think for some reason it wasn't installed. I don't know quite what happened exactly, to be honest, but it wasn't installed, so I couldn't find it when it tried to redeploy. Yeah. Something like that. Yeah, exactly, yeah. So the first part actually works. It did pick it up the first time. I'm not quite sure why it didn't pick it up the second time. But, yeah.
But in that case, so it is sending it across?
It's not, because they were working off the same mods directory in that case. Yeah. Okay. Well, thank you very much for listening. I hope that was useful.